Hi Anshul.
Hi,
So how are you, Anshul? All good?
I'm good. I'm good. How are you doing?
I'm good. Thank you. So Anshul, I see your resume, and I can see you have done a lot of work on big data for last 3 years.
hmm
Yeah. So what are the major things you have worked on in big data stack? Because there are a variety of things, right? So can you please let me know what all tools and technologies you have used?
For data ingestion, I have used Scoop and I have used Hive to a majority of extent, and I have also used Spark for the fast processing at the later part of my project. And along with that, as a part of the NoSQL database, I have used that space.
Okay, that's great. And anything on the AWS side?
I have not used anything on AWS as of now.
Okay. Okay. But do you have idea something on AWS?
Yeah, I have little bit of idea on AWS, like a
Okay.
streak for storage and how to create the job and how the job has to be submitted and all those. So creating a cluster on the fly and something like that, I have some idea on that.
Okay. That's great. That's great. Fine. So as you said, you have worked on Spark for some time. So let us start with Spark, right? So can you tell
Yes,
me
sure.
what is Apache Spark as per you?
So as for me, Spark is a uh, uh, in-memory general purpose computing engine,
Okay.
which is a lightning fast engine, I would say.
Uh-huh. I mean, can you elaborate that a bit? Because uh, I didn't get it clearly. Can you elaborate this? Like what exactly is Spark? Why do we use Spark?
So Spark is actually used for the in-memory processing. To understand this scenario, we'll have to understand that how the previous architecture of big data was, where we used to read the data from disk and we used to process it on over the disk, and there was not much involvement of the memory. But when we came to the Spark, we actually gained some momentum as the data was getting processed, not processed in the over the disk, but in the memory. So that is where we get all the computational speed, and since it's just the engine, so it's just a plug and play, and we can just compute something over memory and save it over our storage. That could be anything like S3 or HDFS.
Okay. So you are saying we can use any storage now, right?
Yes.
Okay, got it. That's fine. So when you have worked on Spark, have you used any of the design patterns, or do you know any of the design patterns in Spark? Or basically, I should ask Scala, right? Because you have worked extensively on Spark with Scala. So every language has some design patterns. Any design pattern have you used?
I have used functional programming in Scala.
Okay, that's fine. But have you heard anything like a factory design pattern or a singleton design pattern?
So I have used the factory design pattern where I had got a chance to use a lot of apply method where I did not have to actually create the object, but just by passing the class name with the parameters, I could call the instances.
Okay. So you have used factory design pattern. That's great. Anywhere you have used singleton?
Yeah, singleton object is quite common in Scala, so we have to use it more often.
Okay. No. So what is singleton design pattern?
So singleton design pattern is a pattern where we do not have to instantiate a class because the object is already available for a class. So we do not need to instantiate it, and we can call all the class member by the class name itself.
Okay. Fine. Great. Um, that's okay. So when you use Spark, you might have used some optimization techniques, right? because as part of good programming practices, we always want to do optimizations. So what are the optimization techniques you have worked on in Spark?
So actually, there has been a lot of optimizations techniques that I've worked on, and so that actually completely depends on the scenario that we encounter in day in day out. So one of the scenario that I would like to produce is like when we had two larger tables. That actually happens more often in Spark when you get more than one larger table and you have to join it, and you there would be a lot of shuffling of data, and there would be a lot of shuffling of data, and potentially you would run a memory out of error in that case. So I had to actually use some partition by function, so that there is a least shuffling of data, and I can get some momentum at that point of time in terms of speed. And also I have used in case of when there is a small table and there is a large table, then I have used the concept of broadcast variable, where the entire table is broadcasted over the node instead of getting partitioned across the across the worker nodes. So that is the second optimization I have used. And the other optimization that I'm aware of and I have used in my projects is like cache and persistent. So if there are multiple actions, if I'm calling it, so every time the DAG is getting created, every time the DAG is getting created, and you'll find that the same DAG is being computed each and every time when I call the multiple actions. So at certain point of time, I plan to cache those plans, and when I execute my program, it will start computing the DAG from that point itself. So that is one of the
Okay,
optimizations that I've implemented uh, in
that's great.
Spark.
That's great. Yeah, Anshul. So that's great. So you said cache and persist. So when to use cache and when to use persist? I mean, I'm just creating a question from whatever you said. Probably you might be aware of it.
Yep. So I would say the cache is something that would hold the execution plan in the memory. When you are well versed with the capacity of the memory that you have, and you know that you have enough memory that you can cache the plan, you probably would go for a cache. But persistence gives you an option to store the execution plan in the memory or over the disk, or with the combination of some part in the memory or some part of the disk. But when you're not sure about the about your memory, when you think that you may run out of some memory exception, you probably go for the persistent by making a combination of that what should get stored over disk and what should get stored over memory, like that.
Okay, okay, got it, Anshul. Great, great. So, Anshul, what is your day-to-day task in your whatever role you are doing in your project? So, what is your role and what is your day-to-day task?
I'm working as a developer in my team. I have a team of five, and we all work as an individual contributor here. And since my project has got so many modules, I'm handling one of the modules of my project, which has the completely financial data. I'm handling that piece, the financial part. So my daily activity is to gather the requirement from the client, and just to incorporate those requirements into a design, so that a feasible solution can be developed in big data platform. And we actually create a report on top of that, which helps my client to take some business decisions.
Okay, so Anshul, I understood this point, but whatever gathering the requirements, design, this might be an activity which might be required once in a month or sometime. But on a day-to-day basis, what exactly is your work in your project?
So I would not say that gathering requirement is actually is done once in a month probably. So this is an ongoing practice. So there are various branches of the modules, and we all have to handle those branches parallelly. So we need to get into touch with the client and gather those requirements, and and some of the ongoing projects where the change requests are proposed, we have to incorporate those also. So if the data mart grows bigger, we just think of the optimization, because these are the reports which are getting done, which are getting populated on daily basis. So we actually examine that what is happening over a period of time. If we examine that in a week the job has got slower, and probably we think of some optimization. So
Got it.
then we go back to our code and think that what are the challenges here to optimize, and how can we bring up some new ideas to optimize it and make the job work better. So this is one of
Understood,
the
Anshul.
activities that we do on daily basis or in terms of optimization. But yes, we do often receive change requests from the clients. For example, if the client is interested in seeing the YTD value of the entire year, probably the client would ask me, just show me the value of this month probably. So this is a change
Got it.
request of client that we need to cater it, and we have to incorporate in the in our design pattern, and finally that those have to be reflected over our reports. So these are actually
Okay.
the
Okay.
activities we do commonly.
Fine. Fine. Good, Anshul. Good. So you are doing quite a good amount of work, it seems. Nice. Nice to know. Uh, so that's fine. Normally, how much data do you deal with in your projects?
So initially we started it off with 18 to 20 GB of data, but every 3 days we receive a 1 GB file from a client and we process it.
So initially you started with 18 GB, and then now every week you get 1 GB. Is it what you're saying?
I would say every 3 days. So in the
Every three
interval of
days.
3 days, I receive a file of size of around 1 GB, and that needs to be processed with the
So
business
that
logic
means,
discussed with the client.
okay. So just a second. So 18 GB and 1 GB is collected in 3 days. So that means you're dealing just with 2 months data approximately. That's it.
It's not just the 2 months data. Actually, there are some APIs at client's end which produces the data on the interval of 3 days. Once that data is produced, that is actually shared on the some shared location where we start collecting it. So eventually, the amount of data that we are processing, which that becomes 2 to 3 GB, that increases by 2 to 3 GB per week. So
No.
if
So
we
initially
started
when you
with 18
started,
GB of data,
uh,
yeah,
uh,
if we started off with 18 GB of data initially, then additionally we get 3 GB of data in a week, and we combine all those data
no, I
and start
understand.
processing.
Just a second. So when you started with 18 GB data, I mean, for how many months data it was?
It was a data of around 4 to 5 months.
No, but when you say that every 3 days you get 1 GB, and when I calculate that, okay, every 3 days 1 GB, then 18 GB would take approximately around 45 days or 50 days. That's like around 2 months, right?
Yes.
So, I mean, how exactly are we saying that it was 5 months data? I didn't get that point.
So actually, the frequency of production of data was different because the
Okay,
18 GB was a data collected from a warehouse.
understood.
So yeah, that was actually collected from a warehouse. So that was an aggregated data probably. So
Understood.
now their live systems are actually uh, going back to few months and getting the relevant data. They have a REST API in place which gets the relevant data for them, which is consumable data as part of the data mart, and then we'll have to combine all those data because the way the 18 GB data was produced was different from how the 3 days data interval is getting produced. So there is a
I
delta
got the
between this.
point. I got the point. Got the point. No, understood. Fine, fine, Anshul. That's good. Uh, so, okay. Now, can you tell me, like, you are using Scala as your programming language, right? You mentioned.
Yeah, yeah.
So, any reasons you are using Scala? I mean, because we could have used some other language also along with Spark.
Yep, we definitely could use other languages with the Spark, but since we all know that Spark itself is written in Scala and Scala blends very well with the Spark, when you compare it with other languages like Python and Java, you would get some momentum in terms of speed of processing. So we opted to go for Scala in this case.
Okay, okay, seems reasonable. Okay, have you encountered or do you know what is a diamond problem in Scala?
Uh, I just have an idea that it is related to the I would say inheritance. Uh, uh, Probably one class might have different subclass, and that particular subclass is being inherited by some other class. So I just have a high level idea about it, but I really have not encountered this ever in my project or in my process ever.
Okay, okay. Do you know what is a trait in Scala?
Yes, that is a way of implementing the multiple inheritance, because when you inherit from the multiple class, there is no way we can do it without trait. There is a concept of abstract class also in the Scala, but that abstract class is not helpful in implementing the multiple inheritance. So using trait, we can use the multiple inheritance Scala.
Okay. So is trait like an interface in Java?
It's yeah, it's like an interface in Java. I would probably say it's like an abstract class in Java.
Why do you say like that? Not an interface but an abstract class?
Because we can just define the data members and the functions, but the implementation has to be done in the derived class.
No, that's the concept of interface also, right? That's
But
the definition of interface.
yeah, but interface is something that I've used in C sharp, and I'm not aware that how it is implemented in Java. I am aware of abstract class in Java, which is very much similar to trait, but it does not help you in implementing the multiple inheritance.
Okay, okay. You know, there is something called as a case class in Scala.
Yeah, there is a case class in Scala. That's right.
Yeah, yeah. So can you tell me more about it? Like, is that helpful in any way? What is a case class and what are the benefits?
So a case class uh, is case classes in Scala is actually used when you define the schema of the data frame. You probably want to go for a case class, and you'd like to define the schema. And the other benefits of the case class is that when you create the case class, you do not need to define the object for it, and you can directly use the case class and call its data members and data objects inside. And the third advantage of the case class could be it has a very handy string method or toString method that you can use. And also, when you do the equality of the two objects, when you create the multiple instances of the case class, or you compare two case classes object, it is comparable. It does not happen when you use a normal class. It will return false. But this time, when you compare the two case classes objects, it will return as true. So they have a comparable objects, I would say. And other than that, it has a very handy apply method that you can use as a part of your factory method, which you can just use with the help of the case class and passing the parameters. So that again is helpful in designing your pattern in Scala.
Okay, okay, great. So, Anshul, I mean, which cluster do you use? I mean, which distribution do you use in your company for big data?
Which cloud era?
Cloudera. So, is it on-premise?
Yes, it is on premise, not on cloud.
Okay, and what's the size of the cluster?
So it's a 18 node cluster.
Okay, and what's the configuration you use for each node?
So it has a 64 GB of RAM, 1 TB of hard disk, and I think 16 cores of CPU. And
Okay,
when you talk about the name node, it has around 128 GB of RAM, and I do not remember the what hard disk it has, but
oh,
I
that's
am
fine.
aware
Name
with
node,
one.
anyways. Yeah, anyways, we do not consider name node, anyways, right? So, data nodes is what matter to a developer. So, that's fine. That's totally okay. Understood. Now, I mean, when we talk about Spark, we have something called as a RDD, right? Can you tell me what is the RDD and why are those given as immutable?
So RDD is actually the in-memory collection of objects.
Okay.
So uh, so they are actually immutable because uh, they are immutable because they usually form the lineage because one identity keeps track of the other, and since once you modify this if you modify something which is in memory, you will lose changes of all the previous you will lose all the previous changes that you have done. So just to keep track of what is being done with in each step, it is kept as a property of lineage where you can backtrack of all the operations. So in terms of optimization, I would say it is highly optimized because it is in memory, and also uh, also it is computed runtime. So unless we call the action, it's not computed. So we gain a lot of performance optimization internally by predicate push down and everything.
Okay. Okay. Fine. Financial. That is okay. So you have worked on multiple big data projects, it seems from your resume. So can you tell me one of the most challenging thing you have faced in your projects, or the hardest thing that you have faced, and which you resolved?
So I just figured out that one of my colleagues in a code while shuffling the data, because there was a requirement of shuffling the data all around the partitions in the worker node. So I just was examining the code that he was getting memory out of exception error. So I just took time in analyzing the code and went through it completely. I figured out that somewhere he was using a group by key operation probably. There was a situation where he needed every key to be in each similar keys and exact keys to be in one partition, and where he used that group by key in the operation as part of the transformation. So so what I did there was like since he was getting a memory out of exception, I introduced the concept of salting, where I generated some random number and attached those random numbers or suffix those random numbers with the keys, all because of which the keys got scattered across different partitions, and we were able to do the joins properly, and we just came out of this with flying colors, and we did not get any memory out of it exception. So I found this to be challenging initially to analyze it and figure it out why it is happening, but this is one of the major roadblock that I was able to move away from the our development path, and that gained a lot of performance out of
Okay,
this.
so good, Anshul. I mean, it's really nice that you solved that problem. By the way, how do you analyze your Spark jobs? I mean, is there a way you analyze your Spark jobs?
When you say analyze, what does that mean?
I mean, how do you know there are performance challenges, or how do you figure out where exactly is the performance challenge? How do you check that out?
We actually look at the size of the data first and the kind of operations and transformation that we are doing in this part. So if we see that some of the operations can be replaced with
No,
a better
no,
operation.
what I mean, do you know how to see the Spark Web UI and how to track a job from there?
Yes, I know. I know to analyze the job. I know to analyze the DAG. So basically, I go to the DAG and see that how many stages are getting created. So if there are so many stages are getting created, then we just think that what approach should we take that we can minimize the number of stages getting created over there. So
Why
if
you
we
want
are
to
able
minimize?
to do we want to minimize the number of stages because the number of stages correspond to the number of data shuffles, which is a very costly operation in Spark. So we do
Mhm.
not, we our intention is to minimize the data shuffle happening all around. So we just go back to our code and see that where are all those data shuffling happening, where are all those stages being created, and we analyze the code that what are the operations or what are the transformation that we can inject to reduce these stages. And when we are able to actually reduce these stages, we see a lot of performance gain because there are least shuffling of data. We completely cannot eradicate the stage creation, because again there are some point where the creation of stages are necessary, the
Understood.
data shuffling
Yeah.
is necessary,
Yeah,
but we
Anshul.
try
So
to
we are
minimize
running. Yeah,
the
yeah.
number.
So we are running out of time. Let me ask last few questions. So basically, can you tell me a few transformations which create a new stage for you?
So the new stage was like a group by key was one of that. That
Okay.
actually created the reduced by key was something that created the stages, because that required the data shuffling. So these were some transformation which created the stages.
So any formal name do we give to this kind of transformations or this kind of things?
These are called Y transformations.
Okay. Okay. So I mean, what are the groupings of transformations? There is something called as narrow also then.
Yeah, there is something called as narrow transformation, which does not require any shuffling of data. For example,
Okay.
the map transformation or the filter transformation, when you apply, does not cause any shuffling of the data. So that these are called the narrow transformations.
Understood. Understood. Answer. So fine. You have worked extensively on Hive too, right? So what all
Yes,
performance
yes.
optimization techniques you have used in Hive?
So there would be a different categorization of the performance. I would say the one was at the table level where we had to actually create the buckets and partition. The other was at the query level where we had to try for the map side join if possible, and we have to structure a bucket map join or short merge bucket map join wherever we feel that is possible or feasible. And sometimes we had to also structure our query in such a way. For example, most of the people do come from the SQL background or database background. They are into a habit of writing the inner queries with in and access. We see if we can replace it with left semi join and all those. So this is something like restructuring and revisiting your query and refining it to a level so that you get some performance optimization. Sometimes we do not go for the map reduce engine, we go for the Sage or the Spark engine, we do it. And the file formats technique also comes handy, where we are not able to decide that which file formats are the best fit for the Hive. We just go for the ORC. And obviously the compression techniques is also helping hand, where we're able to compress the huge amount of data to some less number, and we get a lot of processing momentum while doing all these things.
Okay. Okay. That's good. So when do you use partitioning and when do you use bucketing?
So partitioning, I would say, when you see the cardinality of the row is very high. So if the repeating groups in a column is very high, and you find that the reasonable number of folders can be created, we go for the partitioning. Partitioning, for example, I would say that let's consider an example of a state in a country. You probably would go for a partitioning where you want to consider a state specific data. But when you are actually dealing with some joins and you want to optimize on the basis of joining column, like probably like id and probably which has a very low cardinality, you would go for a partitioning in that case.
ID will have a very high cardinality, right?
High
Cardinality
cardinality.
means a lot of number of distinct values. So I think IDs will be all
Yeah,
distinct, so
that,
cardinality will be high.
yeah. What I mean to say is like the more number of unique values is in the column.
But
More
okay,
number of go for a partitioning. If you find the repeating values or something like that, you find that lot of values are getting repeated. If that those are forming a group, then I would say go for your partitioning, and go for
understood.
bucketing when you see that, and go for bucketing when you see there are non-repeating values in a column, like id. So
Okay.
there are
Okay.
non-repeating values, so probably you would
But
go for a
before
bucket.
but before doing that, won't you see whether this is used in the where clause?
Definitely, this has to be seen actually. So that's what I said. If you have to filter out the data, then you have to. Then this is if something is your frequently queried statement, and you know that this is the basis on which client will filter his reports. Then you will have to identify that particular column, create create partitioning on top of that. But when you are actually joining a lot of tables, and you probably go for partitioning, because you would see that partitioning works best with the joins. And also you would see you will get some momentum in terms of performance momentums when you join all these tables, when you do the partitioning. And when you have to filter the data, when you have all the when the you have unique values in the columns, then you have to filter the data on that basis. You will go for bucketing, not partitioning here.
Okay, okay, got it, answer, got it. That's good. So again, let me ask you one thing. You said you are using Hive, and you are saying you are using Spark. So in Spark, we have something called as Spark SQL, if you are aware of. Then, I mean,
Yes.
it is almost similar, or the way we write things is just like Hive. Then why do we use Hive then? Or why are you using Hive in your projects? Why not Spark SQL?
So uh, we had let me tell you the flow of my project. We actually initiated our project with relational database, where we just had to create the reports on top of relational database with the logic given by the client. But at later phase of time, when the data mart grew bigger, we just thought of moving all those tables to our SDFS, where we created external tables on top of that. So at later point of time, data mart was growing bigger, and we were facing some optimization challenges in Hive. So we started accessing those Hive tables in Spark, where we created data frames on top of that, and wrote some Spark SQL scripts. So these were the in memory computation. So shuffling of data was less, and IOs were less, and so we get a lot of performance benefit in terms of uh, time and uh, but in terms of time and your output.
Okay, okay. So what all transformations you have used in Hive, in Spark majorly in your project?
So uh, uh, when using the core Spark, we have used like map operation is something that we use widely in our projects. The filter operations that we use, then for reduce by key, something that we use more often in our projects. And when it comes to the data frame, we do the optimization like which column, where we had to calculate the additional values and aggregation, all those. So this kind of transformation we use mostly in our projects.
Okay, okay. What is the difference between reduce and reduce by key?
So reduce will do all the aggregation in this on this same machine. So it will not cause any shuffling of the data, but reduce by key will actually take the key into the key into the consideration, and will assemble all the keys into the same partitions, and then do the aggregation.
No, so you said reduce won't do any shuffling of data. That's what you said.
Reduce operation. Uh, what I remember is like
So first of all, let me ask you: is reduce a
so
transformation or action?
so reduce is a transformation, not an action.
And how about reduce by key?
No, I think reduce is an act. Sorry, actually reduce is an action. Reduce by key is a transformation.
Okay, and
So
what's the
reduce by
difference?
key is a transformation. So when you call the reduce, when you call the reduce, what happens? The your master node does all the calculations. There you don't get the parallelism. But what
Okay,
happens in reduce by key? You get the data computed across the various worker nodes, where the all where similar where same keys get accumulated across the across the node, and then does the computation. And unless you call the action, the data is not sent to the driver machine. But in reduce, which is not a transformation but an action, everything is being done on the driver machine. So that's the major difference between these two.
Okay, okay. So let me ask you the last question now. So as you said, you have used file formats for optimization. So there are two kind of basically file formats, row based and column based. When to use what? Can you give me an idea on that?
So the column-based file formats, I would say that whenever you have a scenario like data lake where you just want to land your data and read all the columns, you would go for a row-based. You would go for a row-based file format like Abro. And but when you want to just read few columns and and also you do not want to perform any heavy write operation, I would say that go for the column based file format in that case.
Okay. What are the examples of column based?
So column based would be your RC, ORC, Parquet.
Okay. And what's the difference between ORC and Parquet?
So ORC is actually much more optimized than Parquet. Parquet is majorly used for a nested data where you have like probably like nested data. You would go for a Parquet file, and when you see the but when you don't have the nested data and you want to go for a more optimization, you would go for ORC in that case.
Okay. Which file format works best with Spark?
It's Parquet.
Let's say I do not have nested data, then because you said Parquet is good only for nested data, then I'm saying I do not have nested data and I want to use something with Spark. Should I use ORC or Parquet?
I would say that you should use Parquet in that case because Parquet is the best fit for Spark.
Why?
Like
Why?
ORC is the best fit for Hive.
Any reasons you say best fit? Why best fit?
Because it contains the metadata along with the data.
So I mean, does ORC does not contain that you are saying? Only Parquet contains?
It does contain the metadata also. ORC.
Yeah. Then why do we use Parquet? Okay, no worries, Anshul. That's good. So I think we are done with it, Anshul, and it was
Yep.
really nice talking to you, right? So I mean, we'll get back to you based on the results, and the HR will contact you shortly, Anshul.
Okay. Thank you. Thank
Yeah,
you.
yeah. Thank you so much, Anshul. Thank you.